Okay. So in previous session, we talked about operators like arithmetic operators, assignment operators, logical operators, and comparison operators, right? We've seen the examples also how to perform all these operations, right? So today we are going to talk about identity operators, membership operators, and bitwise operators. Okay. So what are the identity operators we have? So identity operators we have is not. Okay. And what about membership operators? We have in, not in. Okay. These are the membership operators. These both operators are very, very important for us because while doing our testing, we are going to use all these operators, even comparison operators and identity operators, membership operators. Okay, because we are going to check something in our testing, actual and expected values, right? In that time, we can use all these operators. Okay. Now, what is the is operators will do? Identity operators. Okay. So generally, identity operators, it will check the presence of, sorry, it check the object reference. Okay. It will check the object reference. For example, let me comment out all this. Okay, let's say A equals to 10, B equals to 10. Okay, here, if I use identity operator, print A is B. Okay, so what will happen? So it will return Boolean value, either true or false. So generally, identity operators, it will check the object reference. Okay, it will check the object reference, means memory location, whether both are stored in the same memory location or different memory locations. Okay, so in this case, this will return stored in the same memory location or different memory location.
Same.
Both are immutable data types, integers. It will point to the same memory location. Okay, if you guys remember, this will point to the same memory location. Okay, so now if I use A is B, what does it mean? Whether it will return true or false?
True.
True, because both are stored in the same memory location. Okay, now if I have a 20, if I try BC, what does it mean? It is pointing to the different memory locations. Okay, here it is not going to check the values, it is going to check the object reference. Okay, memory location. Okay, if both values are in the same memory location, it will return true. It will return true, or else false. Okay, so what about is not? It will return opposite value of whatever the statement is there. It will return is not meant, it will return false, opposite value of actual statement. Okay, so how to check the memory location?
DIR.
ID, right? So ID method, what it will do, it will return the memory location. Okay, so here let me print what is the memory location of each variable. Okay, ABC. Okay, let's run this file. See, A and B are both are storing it in the same memory location. Okay, that is the reason A is B, that is true. Okay, and C is located at different memory location. So in this case, A, B, C false. Okay, now another one is A is not B. So here both are storing same memory location, but I am using not. That means whatever the actual statement A is B, right? That opposite value will be written false. Okay. So that is the uses of identity operators. Now, if I have another example, let's say, okay, so this time, if I use A is B, what does it mean? What is the statement? True or false? Hmm?
True.
False.
Okay, so here what type of data types it is?
Mutable data.
So list, it is mutable data type. Okay, so both are storing into the same memory location or different memory location.
Different memories.
Okay, it will point to the different memory locations. Okay, so in this case, if I use A is B, what does it mean? What will be the statement? False, right?
False.
Both are storing in a different memory location. If I use A is B, it will be false. Yeah, let see false. Both are storing in a different memory locations. You can see the memory locations 91205328. Okay, so that is the uses of identity operators. Okay, now we have other operators like membership operators. Member. Okay, so here generally there is a one important interview questions. And is what we can say double equal. What is the purpose of equal? To compare the values. Okay, it will compare the values, not the object reference. Is operator, it will doesn't matter the values, it will compare the object references, memory locations. Okay, that is the one point we need to remember. Now we have membership operators like in, not. Okay, so these operators we can use, we can use to check the presence of values, to check the presence of the values in any sequence data. Okay, so sequence in the sense either string, list, tuple, dictionary, set. Okay, so how we can use these variables? Let's say here we have a, b, right? 1 2 3. I want to check 2 is there in my list or not. 2 in a, so what it will return? 2 is there or not in the a list? It is there, right? It will return true. Okay, so in operator just it will check the presence of values. So 2 is there in the a list. If it is there, it will return true, always false. Okay, for example, a in my what does it mean? What is the output of this line?
False.
False.
Because there is no character called a. Okay, so that is the uses of in operator. It will check the presence of the values. Okay, so if I use not in, it will return the opposite value. Let's say this time what will be this output?
Yes. True.
So not only single character or digit, we can check substrings. We can check multiple values. Okay, so MSN in, it is there. If it is written, it will true. If I use not in, what will be the output? False, right?
False.
Okay. So this is the way we can use the membership operators. Okay. Now, so there is one more concept here. We haven't talked about this one, like shallow copy, deep copy. So here also, maybe we can discuss as a separate topic after looping statements. Okay. So shallow copy, deep copy means deep copy only copies the values, not the object reference. Shallow copy copies the values along with memory location. Okay. That we will discuss as a separate topic. Okay. In that time also, you can use all these operators. Okay. So these are the membership and identity operators. Okay. I hope it is clear. It is pretty straightforward. Okay.
Yes.
So now we have other operators called bitwise operators. So bitwise operators, we won't use much, but be aware about what are the bitwise operators we have. So bitwise operators we can perform based on the binary numbers. Bitwise operators are performed based on the binary values. Okay. So what are the binary values? Binaries are like zeros and ones. Okay. So what is the equivalent binary value for 0? Excuse me. 0, 0, right? What about 1? Anyone remember? What is the binary values? 0, 0, 1. Anyone from EC background? CSC background?
Yes, bro.
So
Yes,
anyone come across these binary values? Is it correct? So these are the binary values, right? It is having zeros and ones. Okay. For 4 we have 1 0 0 5 1 0 1, something like this. It will go on. Okay. So now to perform the binary operators on the binary values, we can use bitwise operators. Okay. To perform the operations on the binary values, we can use bitwise operators. What are the bitwise operators we have? So we have bitwise and, or, XOR, not, left shift, right shift. Okay, so these are the bitwise operators we have. So how we can use these operators? Let's say, so let's say A and B. Okay, assume that A and B. I'm going to print A and B. A equals to 2, B equals to 3, something like this. So how AND operator will work? Okay, so here, what is the equivalent value of 2?
0, 1, 0.
Let's go for here. 0, 0, 1, 0. Okay, 0, 1, 0. It is for 2. What about 3? 0, 1, 1. 0, 1, 1. Okay, so if I perform AND operation, so generally AND operator, how it will work? Whenever we have both sets are 1, it will set 1. Otherwise, it will set 0. Okay, that means sets each bit 1 if both bits are 1. Okay, in this case, here, right, 0, 1. What is the output? Either you can go from here 0, 0, 0, 1, 1, 1, 1, 0, 1, 0. Okay, so whenever we have both bits are 1, then only it will set 1. That is the AND operator. Okay, bitwise AND operator. So what is the equivalent value for this one? 0, 1, 0, 2, right? The output will be, so what is the output of A and B?
2.
2. Okay, so AND operator, whenever we have both sets are 1, then only it will set 1. Okay, that is the AND operator. Okay, let's run. You can see 2 is the output. Okay, so what about, let's say, with another example, maybe we'll go for 1 and 5. Okay, 1 and 5. Okay, so what is the equivalent value of 1? 0, 0, 1. What about 5? 1, 0, 1.
1, 0,
1, 0, 1. Okay, so in this case, so what will be the output? So here 0, 1, 0, 0, 0, 0, 1, 1, 1. Correct?
0.
0, 0, 1.
0, 0, 1. So that is equivalent to
1.
1. Okay, so can we expect here 1 as the output? You can
Yes.
Yes.
see 1 is the output. Okay, so this is the way we can use logical AND operators. Sorry, bitwise AND operator. Okay, let's move to OR operator. OR operator, it will set whenever we have each bit is 1, any one of the bit is 1, it will set the 1, otherwise 0. Let's say same thing I will copy. Maybe this one. Okay. OR operator. Okay. So here 2 or 3. Print 2 or 3. So this is the pipe symbol we can use for OR operator. Okay. It is there in the above enter key. Okay. Pipe symbol. So here, if we have any one of the bit is 1, then only it will set 1. If both bits are 1 also, it won't set 1. Okay. Only any one of the bit is 1, then only it will set 1. Okay. So in this case, okay, not only either 1 bit or 2 bits are 1, then only it will set 1. Okay. So in this case, what will be the output? 0, 1,
3.
1. Okay.
1.
So either single bit or 2 bits are 1, then only it will set 1. Okay. So 0, 1, 1. What is the equivalent value of this? 3.
3.
Okay. So this is OR operator. Okay, let's see. See, this is the output. Let's comment out above the statements. Okay, so this is the uses of bitwise OR operator. We have XOR. So generally XOR, only if one bit is 1, then it will set the 1. Otherwise 0. XOR. This. Okay, XOR. So XOR operator is cap. Okay. So here only one set should be 1. Then only it will set 1. Otherwise 0. So in this case, what will be the output? 0 0 0 1 1 0 0 1 1. Okay. What is the equivalent value? 2 cap 3. Okay. So 1. This equivalent to 1. I hope it is clear. So when we have any one set only 1, then only it will set 1. Otherwise 0. Even though if you have two ones, it will set 0. If you have only one set is 1, then it will set 1. Okay. You can see 1. Okay. So this is the uses of XOR. Okay. So if only one value is 1, it will set 1. Otherwise 0. Okay. What about R? If anyone value is 1, it will set 1. Okay. Otherwise 0. What about AND operator? What about AND operator? If both values are 1, it will set
1.
1. Otherwise
0.
0. Okay. So these are the bitwise operators we have, and we have not. So not, what it will do, it will return the opposite value of any statement. Okay. There are shift left, 0, left shift, right shift. So it will move the points to the left side or right side based on the values. Okay. I hope after this point is clear, operators.
Yes.
So from the previous session, we discussed arithmetic operators, assignment operators. So here, if you see the assignment operators, right? Here we have bitwise equal. So how we can use in the similar fashion? So let's say I have a equals to 2, but I can a and equals to 3. So what it will do? Similarly, this is equivalent to a equals to a and b, a and 3. Okay. So whatever the outcome we'll get from a and 3. So 2 and 3, 2 and 3, the output will be 3. Okay. The 3 is going to assign to the a variable. Okay. The output will be 3. Okay. So this is the uses of assignment operators along with bitwise operators.
There.
And, okay. What is that? So this is the syntax we can use. Not sure why it is giving error. End of statement expected. Okay. So like this, we can use assignment operators along with bitwise operators. Okay. If you want A XR equals to B. Okay, it is equivalent to what is the equal statement? A equals to A or B. Okay. So the output will be stored into the A variable like this. It is clear?
Yes.
Okay.